by 4.9, all square rooterized. You need the h in meters. So I type into my calculator 70 divided by 4.9 equals, and then I square root that answer and I get 3.77. Please make sure that you can type in that into your calculator and get the appropriate answer here. There are different ways of typing it in, and some of them are wrong. There are several different ways of doing it right. Make sure that you can do it as well. Number 2, an object drops for 8 seconds. How far did it fall? So I'm going to use the same equation, but I'm going to solve for a different variable. This time I'm going to put the 8 in for the t, and I'm going to solve for the h. I want to find the height. So the first step in doing this is to square both sides. That way the square root and the square cancel out. So on the right-hand side, I have 64. On the right-hand side, I still have the fraction. And then I multiply both sides by 4.9. 64 times 4.9 is 313.6. Meters. Number 3, an object drops for 5 seconds. How fast does it hit the ground? Okay, so in the previous equation up here, we have t and we have h. We don't have a velocity v in that equation, so we can't use that. So what other equations have velocity in it? Well, we have an equation that says v equals displacement divided by time. And we have acceleration is equal to the change in velocity divided by time. Can we use either one of these? In the first equation, we do not know how far it falls. And so that is not going to be a very good one to use. In the second equation here, we are not initially given the a in the story problem, but we know it because this object is falling, and so we know that its acceleration is going to be negative 9.8. The time of fall is 5 seconds. We want to know what the change in velocity is. It starts off at 0, so any change in velocity is going to be the final velocity. Okay, so to solve this, we multiply both sides by 5. And I get negative 49. Any questions on those 3 problems? Number 4, an object drops 12 meters. How fast does it hit the ground? One way of doing this is to have it as a 2-step problem. In the first step, we're going to find out how long it takes to drop, and then we will find in the second step how fast it hits the ground. So this is how many seconds it takes to hit the ground. 1.56 seconds. And now, just like we did in the previous problem, we'll use the acceleration to figure out the speed of hitting the ground. The acceleration is negative 9.8. The time we just figured out is 1.56, and we're looking for the change in velocity. Negative 15.2. Let's see here. I guess it's 0.3 if we round to the nearest tenth. Number 5. An object is tossed up at 10 meters per second. What is the acceleration at all points in the flight, going up and coming down? Think about it, think about it. I hope you came up with the answer of negative 9.8 meters per second squared. Number 6, an object is tossed up at 100 meters per second. How fast is it going after 1 second? Okay, to do this conceptually, when we say the acceleration of gravity is negative 9.8 meters per second squared, I can rewrite this as negative 9.8 meters per second. So that means that the velocity changes by this much every second that passes by. So after 1 second of being tossed up, our 100 changes by the negative 9.8. So 100 minus 9.8 is going to be 90.2. After another second, this changes by another negative 9.8. So I take the 90.2 minus 9.8, and I get 80.4. So it's going to get slower and slower until it comes to a 0, and then it's going to get more and more negative as it comes down. Number 7, an object is tossed up at 10 meters per second. How fast does it hit the ground? We could use equations for this, but there is a shortcut without any calculations whatsoever. Do you remember it? You write down the exact same digits, but it's coming down to hit the ground, so it's negative. An object is tossed up. It's in the air for 6 seconds. How fast was it thrown up? Go ahead and give this one a try on your own. We had an equation that we derived that said that the launch velocity is equal to 4.9 times the time in the air. So V is equal to 4.9 times 6. $29.4. A motorcycle goes 20 meters per second on horizontal ground. It leaps off a 17-meter cliff. Find its range. There are two steps to this. One is to find the flight time, the time in the air. And then there's a second step, which is to find the range. Do you remember what the two equations are? To find the flight time, we use that one. So that's going to equal the square root of 17 over 4.9. I get 1.86. And then to find the range, the delta x is the range, the Vx is the velocity given to us, and the t is what we found out a moment ago. $37.25. A motorcyclist runs on horizontal ground. The rider leaps off of a 17-meter cliff and lands 13 meters from the base of the cliff. How fast was the rider going? We're going to have two very similar steps to before, but there's a little twist at the end. But the first step is the same. Find the time in the air. And it's the same numbers as before, and so we better expect the exact same answer. The second step is a little bit different. We are wondering how fast it was going, and so we're going to solve for the Vx. That's going to stay a letter. We know the horizontal displacement. It moved horizontally 13 meters. And the time of that movement was 1.86 seconds. So dividing both sides, I get 6.99